All right, so we're going to walk through the rotation of the conic, and I'm going to record this because we're probably not going to finish it. So A is 4, C is 4, B is 8, and the cotangent of 2 theta equals what?
It's pi over 2.
Yeah, but what's the formula? Because it's the one you have to memorize.
Oh, it's A minus C over B.
Good. So cotangent of 2 theta. This time it wouldn't have really mattered, the A and the C, but that order is important for most of them. Over 8, I get 0 over 8. So because cotangent is 0, you're saying that tangent of 2 theta would be undefined. And that happens at pi over 2. So you're saying 2 theta equals pi over 2 and theta equals pi over 4. If you get to know those values, I mean, there's really so many that you can do. Like, there's a fixed amount that I could give you that would fall in your unit circle. So you're either going to get pi over 6, pi over 3, pi over 4, pi over 2. And then from there, you know, you should be able to know your point. So as long as you know that first quadrant, you're okay. But you want to make sure you at least know that stuff. So that's like one checkpoint. You'll get a couple of points for that part. Then comes finding the x and the y. So this is the equation that you'll be given. This is the only equation you're going to get given on your whole test. So x equals x prime times the cosine of theta minus y prime times the sine of theta. That's a minus. And then y equals x prime times the sine of theta plus y prime times the cosine of theta. So x would equal x prime times the cosine at pi over 4 minus y prime times the sine at pi over 4. This would be root 2 over 2. And I can simplify that into one fraction. And then the same here. This would also be root 2 over 2. And then this is the second checkpoint, which you'll get credit for. Then when I plug it back in, I'm actually going to drop off the primes. I just need to make sure that when I put the answer for the standard form of the equation before I graph it, that I bring them back in. So everybody's okay up until this point? Yeah? Okay. So now I'm going to plug them in. So 4 times root 2 x prime. Actually, I'm going to drop it off. X minus root 2 y over 2 squared plus 8 root 2x minus root 2y over 2 times root 2x plus root 2y over 2 plus 4 times y squared root 2x plus root 2y over 2 squared plus 7 root 2x minus root 2y over 2 plus 9 root 2y, root 2x plus root 2y over 2 equals 0. And if there was a constant in there, there's not this time, but if there was a constant in here, I would bump it to the other side. Okay, so now I'm going to go through and individually simplify these. So the squared terms, we said that if that's a binomial square, that you can actually use your the shortcut, which is square the first, square the last, and then 2 times the product of them is my middle term. So the 4 is still on the outside. The square of this would be 2x squared. That's the first term. The square of this would be 2y squared. That's the last term. Multiply the 2 together. I get negative 2xy, and double it. So it's negative 4xy. That's the middle term. And then on the bottom, that 2 is also squared, so that's a 4. And then I go to the next one. This time, it's a different shortcut. This is the difference of 2 squares. They're both exactly the same numerators, but one's got a plus and one's got a minus. So I can square the first term. So the 8's still on the outside, but I can square the first term. So I'd get 2x squared. Square the last term, it's 2y squared, and put a negative between them. That's the flip of the difference of 2 squares. And then 2 times 2 is 4. And then I go to the next term. Yeah, it's only going to happen like that if it's pi over 4.
So we can't, before we start FOILing it out, we cannot multiply the entire thing times 2.
You can, but it's only going to cancel from half of your 2's.
Oh, okay.
Right, because that 8 has 2 2's. It's not going to cancel out both of them. Yeah, because think about it, it would have been 4 in the bottom. If I multiply by 2, there'd still be a 2 left. Yeah. You're welcome. So I typically wait till I expand it, and then I cancel out what I need to. Okay, so then this one would be 4 on the outside, and I'm going to use the shortcut again. This time it's the square of the first term, which would be 2x squared. Square of the last one, which would be 2y squared, and then double the product. So the product would be 2xy. 2 times that is 4xy over 2 squared, which is 4. And then I'm going to leave these for now because there's nothing to simplify just yet. I'm going to zoom out so we can see the whole thing. So typically at this point, there's some way to reduce your denominators. If they were all 4, I'd multiply everything by 4 and cancel them out. This time they're not all 4. They're all, some of them are 4, but some of them are 2. And there's two ways I could have approached this, because if you look at the ones that have 4 in the bottom, each of them have a numerator that would cancel into that 4. So you can also simplify it at that point. Like, make it as easy as you can. So if I had done that, like 2 would go into 4 2 times, that would be 2, this would be gone. 2 would go into 4 2 times, this would be gone. 2 would go into 4 2 times, the 4 would be gone, and the 2 would be gone. So only if you can cancel into each of the individual ones with the same number can you do that. But this time you can. And then all the denominators are 2 for the entire fraction, or the entire problem. So now I can multiply everything by 2. And this is now gone, this is now gone, this is now gone, this is gone, and this is gone. And I would multiply the 0 times 2, but 0 times 2 is still just 0. So now that's gone as well. So I've got, in this first one, a 4 on the outside, x squared minus 2xy plus y squared, plus 8x squared minus y squared, plus 4x squared plus xy, oh, this should be a 2. 2xy plus y squared plus 7 root 2 times root 2x minus root 2y plus 9 root 2 times root 2x plus root 2y. So now I've got this full thing without any denominators, but I've got all the coefficients on the front, which means I've got to distribute those in. So I'm going to distribute in the 4. I'd get 4x squared minus 8xy plus 4y squared. Distribute in the 8, positive 8x squared minus 8y squared. Distribute in the 4, 4x squared plus 8xy plus 4y squared. Distribute in the 7 root 2. So 7 root 2 times root 2 becomes 7 times 2, right? Because root 2 times root 2 is 2. That's 14x. And then negative 14y. And then distribute in the 9 root 2. 9 root 2 times root 2 becomes 18, because that's 9 times 2. 18x plus 18y equals 0. Not yet. So now I'm there, okay? So my entire goal in doing this process is to do what? Get rid of the x, y term so I can get this in a standard form. So the first thing I would do at this point is identify where my x and y terms are and make sure they cancel out. I got a negative xy and a positive xy, or 8xy and positive 8xy. Those cancel out, so I know I at least am on the right track to here. If they do not cancel out there, you did something wrong. Go back and try to find it before you go any further. Okay? Monica.
For the board that has the 8 in front of it, where does the 2 cancel out with the 4?
So the 8 here, this one, the purple one, I did 2 into each of these, right? 2 into the 2, and the 4. So I was left with x squared minus y squared over 2. And then the 8 was on the outside. But then I multiplied the entire equation by 2 to get rid of all my denominators. So it was gone. You're welcome. Okay, so now I want to combine together all of my x squared. So I've got 4x squared, 8x squared, that's 12x squared, plus 4x squared, I'm at 16x squared. And then I want to count all my y squared. So 4y squared minus 8y squared, so I'm at negative 4y squared, plus 4y squared. I don't have any y squareds. What does this already tell you that this equation should be? A parabola. Does it make sense? I only have one squared term. So now all I want to do is group together the x's. So I've got positive 14x and positive 18x. So that's a positive 32x. And then I've got negative 14y and positive 18y, positive 4y. So again, as soon as I get rid of that second squared, I know this is now a parabola. Parabola is the y squared or the x squared. In this case, it's going to be x squared. So it'd be x minus h squared equals 4py minus k. So that's what I'm looking to get into standard form. So I'm going to group together the 16x squared and the 32 on the left and move the 4y to the right.
Make the 4y squared canceled out.
Yep, I had a positive 4y and a negative 4y. No, I had a positive 4y, and a negative 8y. All the gray circled ones.
Okay, then I see.
Yeah. So that's not a perfect square on the left-hand side. I'm going to have to make it a perfect square. I would take out the 16. X squared plus 2x, leave the space, equals negative 4. Take the 2, divide it by 2, it's 1. Square it, it's 1. Add it in here. Multiply it by the 16 before I add it over here. The left is 16 times x plus 1 squared equals negative 4y plus 16. Take out the negative 4 because the y can't have anything attached to it. And this x can't have anything in front of it, so divide both sides by 16. Maya. You sure can. So the question is, can you simplify it at the beginning? You can simplify it any way you want. Okay, you could start from up here and taken and divided them all by 4. You would have still gotten the same answer. I'm going to give you a line on the test that says, what is theta? You're going to get some points, little points, but some points for theta. Then it's going to ask you for x. Then it's going to ask you for y. And then it's going to ask you for the standard form of the equation. When you go to write the standard form of the equation, you better give me back the primes. Okay? So this would be x prime plus 1 squared equals negative 1/4 y prime minus 4.
We have to graph it on the test.
Yes. Yeah. So like I said before, and I don't know if you heard me, but I said this one you had to complete the square and rotate it. You're not going to have both, but you are going to have them separate.
Right.
So you're going to definitely have complete the square on its own, and then you're obviously going to have the rotation on its own. It's just that when you rotate it, you're probably going to have one that's not already in standard form, but you won't have to complete the square to get it into standard form.
So would we have to graph that equation?
Yeah, right now we're going to graph it. Because that could be just a graph of a parabola you'd have to graph. Yeah. It's just that you won't have to rotate it and graph it. So we said that this was pi over 4, right? Which means that on my original curve, I'm going to rotate it pi over 4. So this is pi over 4. So what can you tell me about this parabola? An x squared tells you it's what? It's going to be up or down, and that's a negative 1/4, right? So your 4p is negative 1/4. No, yeah, your 4p is negative 1/4, which tells you it faces good down. So I know this is already a parabola that's going to face down. What? I said left? Oh, she. Oh. It's okay. As long as you know before Wednesday, you're okay. What about the vertex on this parabola? It's negative 1/4, right? Opposite of what follows the x, opposite of what follows the y. So I'm going left 1, 2, 3, 4, up to there. And I know it's downward facing. And honestly, with a rotation of an axis, that's about as much as you need. Okay? For the individual question that would be parabola based, I would ask you for the focus and the directrix. So to get that, I would say you'd have to find p. So negative 1/4 would equal 4p. Divide both sides by 4, and p is negative 1/16, which means down 1/16 from here is your focus. So I'd get -1, and then 4 minus 1/16 is 3 and 15/16. That's your focus, because it's 1/16 lower than your vertex. And then your directrix, again, I wouldn't do this to you on a rotated axis, but let's just say I wanted the directrix here. It would be 1/16 above your line, so without the rotation, it would be 1/16 higher than 4, so it would be a y equals 4 and 1/16. But again, that's not on the rotation of the axis, that's if it was straight up or down. Mauricio.
So the axis rotates to the left, right?
Yes, the axis is always going to rotate counterclockwise. Think about your unit circle, right?
Yeah. So what rotates right?
When I asked you to graph it, I said it's easiest to turn it back right. So you would basically have taken this and flipped it back that way if you wanted to see it vertically.
Yeah.
But you'll leave it on your graph. It will stay that way because you can rotate your paper, but your actual answer should be rotated like that. No. For a parabola, I'm looking for the vertex and where it's facing, up, down, right, left, whatever. For a hyperbola, I'd obviously be looking for you to count out and up and down the A and the B, do your asymptotes, and find the vertices that way. And then for an ellipse, the vertices and the covertices. So find your center, count up and down, right, left, your A and your B, and then give it to me. So, but you're not going to do like a focus on the rotated ones. Yeah. Mikhail. 15. Yeah. So this is the big one, and then there's one where you have to like put it in standard form. I think that's the ellipse. Put it in standard form, find the center, the vertices, all that sort of stuff. So there's a couple multi-part of this. But then you've got one where it's like classify it. Is it a circle or a parabola or a so they're not all equal weight, obviously.
How many are graphing?
What did I just count? 5, right? There's an ellipse, there's a hyperbola, there's a rotated conic, there's the parametric equation, and a parabola. 5.
For the rotated ones, is it usually like pi over 2?
It's either going to be your theta is either going to be pi over 3, pi over 4, pi over 6, or pi over 2. Because you're going to have to rotate it within that first quadrant. It can't exist outside that, but I'm telling you only to learn your first quadrant, so you don't have to. Yeah. Any other questions on the rotation of the conic? So there's an odd question on the homework as well that the answer's already on there, okay? So make sure you know how to do that again. Mauricio.
Is there any more practice on this?
On the rotation?
Yeah, on the thing before, the rotation.
Yeah, there's one more on there.
And then iTunes U.
And then there's a couple in iTunes U. Yes, they're separate, but there's 2. I think there's 2, and I worked out the entire question. Yep.